Hello and welcome to Group 6 presentation in EME 303, Fall 2016. I am William Romanowski.
I'm Mark Madron.
I'm Riyan Choudhury. I'm Tim Laubscher.
I'm Kevin Casey.
And we are going to be studying the hypotheses of what causes the bottom of a bottle to break after hitting it with your hand. Now, when we studied this, we did some extra research online and we found two different hypotheses, which they will be showed in the video above of what happens.
So, if I'm right, okay, bottles, it should break right there. No? Yes!
And we have this video too. As you can see, when the person strikes the top of the bottle with his hand, the bottom of the bottle breaks and falls apart. And we came up, like I said before, with two hypotheses that can explain this theory.
So the two hypotheses we developed that would explain this theory are one, an air pressure wave, and two, cavitation. The air pressure wave would be due to a compressed air shock wave, and the cavitation due to a force from the cavity collapsing.
Alright, so we'll get into more analysis of the air pressure wave. So when you hit the top of the bottle, the compressed air travels through the bottle's neck as a shock wave until it reaches the water level. Since water is basically incompressible, this force is sent through the water. And the pressure is the force over an area. So this force at a smaller area around the neck, around 5 centimeters squared, is transferred to the area of the bottom around 30 centimeters squared from an average bottle. So if we go into more of this theoretical example, if you apply 10 newtons to the top, you get a pressure around 2 newtons per centimeter squared. And then so the force at the bottom is that same pressure times the area, which would be around 60 newtons. So it is around a force increase by a factor of 6, which will cause the bottom of the bottle to break out.
The way the cavitation theory occurs is that the impact of the bottle causes the bottle itself to speed downward, while relative to the bottle, the water accelerates upward. When a fluid accelerates upward, it causes a low pressure area at the bottom of the bottle. And if the low pressure area gets to about 3.2 kilopascals, it hits vaporization pressure for water, which causes a cavitation. As the cavity collapses, the force of the collapse causes the bottom of the bottle to break and to leave the rest of the bottle.
So we've concluded that air pressure wave is improbable from the video, and it's also important that the fluid is water because a carbonated drink or beverage would cause CO2 to form and cushion the force and fizz out. Thank you for your time for watching. Thank you.